There's a question right on the board, and you can see why 2025. The question is on set, and we're asked to look for these questions. These are the questions there. It said, given that this one means universal set. Universal set, I have not talked about set as a topic, but it's a collection of all the items in a particular entity. Universal set. Just like we are talking about in a house. We have chairs, we have plates, we have bags, we have different things. But in the whole, in that house, is what all the things in that house is just inside that particular room. So in that particular room, that room is just like what we call the universal set that carries so many things. So that's how universal set is. Now, his son there, because we are told that. Let me now interpret what you are seeing right here on the board as the question. Is the first question there. So given that the universal set S is such that, that's the meaning of this dot dot, such that 1 is less than X is less than 20. So what we are dealing with now, the range of value in that universal set is between 1 and 20. That is in between, because it is less than, not less than or equal to. I have talked about inequality before. So from what you are seeing here, the numbers could be 2 to 19, not including 1 or 20, because it is less than. If it is less than or equal to, we include the value. Take note of that. Where X is an integer, it does not have a decimal number. Now S is such that S is a multiple of 3. That's why I brought out the elements of P here. What are the elements of P? P is a member of this universal set. Just like I said, in a room, we have the bag. In that bag, we have some items inside that bag. Those items inside that bag is more or less like the elements. The bag in the room is just like a member in that room. I guess you understand what I'm talking about. So having known this, we are now bringing out the list of the numbers, the elements inside that bag, in trying to make a kind of similar explanation with what you are having here on the board. Here, P is a multiple of 3. If you have checked my multiplication video, you will see that I taught you multiplication through multiples. Multiples of 3 are 3, 6, 9, 12, 15, 18. So you can see it falls in within that range. 3, 6, if you add 3 consecutively, you are going to get the multiples of 3. Then they now told us that Q, S is such that S is a prime number. What are prime numbers? Numbers that are divisible by themselves and just 1. No number can divide them. Just they are divisible by themselves and 1. And we find out the numbers. Remember, don't forget, S is such that S is formula. And remember that the range of value we have here, 1 is not included. We don't include 1. So the prime numbers start from what? 2. No number can divide 2 except 2 and 1. 3, 5, 7, 11, 13, 17, and 19. These are the prime numbers in within that range that we can find there. That is the elements of Q. Now, what's the question? We now go to the solution of the question. Solution. I was only explaining the question for us to know how to solve the question. Now, don't forget, whenever you see something like this, we call this one intersection of a set. Intersection of a set is what is common to two sets. Intersection of a set is what is common to two sets. But before we talk about that, don't forget, we have something here which we call Q prime. What Q prime means is that what is in the universal set that is not found in Q. Something that is in the universal set that is not found in what? Q. So because we have to get before we now form their intersection. So let's talk about Q prime. Let's bring out the element in Q prime. The element, what can you see in Q? Q, we don't have what is not found. The universal set, we have 2, 3 to up to 19. Then let's look for the numbers that are not found in Q. I've gotten 2, 3, 4 is not there. 4 is not found in Q. 5, 6 is not found in Q. We are listing it out. Then 7 is found, 8 is not there, yes. 9 is not there. Then 10 is not there. 10. Then 12 is not there. 12, 14 is not there. 15 is not there. 15 is not there. What again? 15, 16, 17, 18, 19. 18 is not there. 18 is not there. 18, at least we have 19. So we can see that the element of a Q prime, what is a Q prime? What is found in the universal set that is not found in Q? That is the meaning. What is found in the universal set that is not found in Q? Remember your universal set, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 19. Don't forget that. So now let's go. We are going to look for what is common between Q prime and P. What is common between these two sets? What is the number that is common? Is what will now give us our number one, our A question. What is common? The QP intersection Q prime is equal to what is common. Check what is common now. You see that if we check what is common between P and Q prime, we see 6 there as the first number. 6 is common. Let's check again. What is common between 6 is common. Then what is common there again? We have the next number. Do we have 9? 9 is here. 9 is common. 9 is common. Then do we have 10 there? No. Do we have 11? No. Do we have 12? 12 is common. 12 is common. Then what again? What's 12? After 12 we have 15. 15 is common. 15 is common. Then 18 is common. So you can see that what is common between them, that's what we call intersection. Whenever you see this symbol, we call it what? Intersection. What is common between the two sets? We succeeded in bringing. So this is exactly what we have. If you care to know more about this, I think let's go to the next question. Let's go to the next question. P prime. We have to list out the P prime first. Let's get our P prime, not P. If you have